All right, so we're talking about angles, okay? So an angle would be something like this. This is angle ABC, okay? And you could call it angle B, change that to a B, because it always labels it by what we call the vertex. Or you could use all the points, angle A, B, C, okay? If an angle is less than 90 degrees, this is 90 degrees right here. If it's less than that, it's called acute. If it is greater than that, it's called obtuse. And if it is exactly 90 degrees, it's called right. Okay, think of it as acute little angle. Obese is an obtuse is an obese fat angle is what I'm trying to say. Okay, and again, we measure them by how much they open. So I would say this is at 0, and I put it on a protractor, and it would say, oh, this is open 120 degrees. All the way around the circle, that would be 180 degrees, that's halfway. And all the way around, that would be 360, okay? So now that we've shown you how you measure that on a protractor, okay, the next one is a bisector. It cuts an angle or line into 2 equal parts. There's no special symbol for it, okay? But if you have an angle, a bisector makes this piece the same size as this piece, okay? Or here, if you have a segment, this right here could be a bisector. It made this piece, if this whole thing was 10, now this piece is 5 and this piece is 5. It cuts it in half, okay? Next, congruent. Congruent means exactly the same. Figures and shapes are congruent, okay? They are exactly the same. Everything matches. So this is the symbol, okay? This could be the triangle ABC is congruent to triangle CDE. Okay, if you're talking about a triangle, then if you drew it, this might be A, B, C. This one would be C, D, E. They're 100% the same. This corner A has the same size as this corner, oops, I should have said, yeah, C. Okay, this corner B opens up the same as this corner D. The angles open up the same, and this leg is the same size as this leg. They match exactly. If you're talking segments, it means they have the same length. So if this was AB, then this could be CD. They're 100% the same. Well, the only thing we know about a segment is how long it is. So this length is the same as this length, okay? Next, a line. It's continuous in both directions. It's not just that's not a line, that's a segment. A line has to have the arrows. This is the picture of it. This is the name. There's actually a million points, infinite number of points on this line, but you just need 2 to give it a name. Next is a segment, same thing, but it doesn't go on forever. It's just a piece. Okay, so this is the line AB, and then this orange part is the segment. Okay, now we're talking about how big something is. This is the measure of angle ABC? How much does it open? Okay, so maybe this is angle A and it opens 70 degrees. It's talking about how much on the protractor. Next is the midpoint. It's the dot right in the middle, cuts it in half. Okay, next is parallel. Lines are equidistant and never intersect. Okay, just like the L in parallel, the L's don't ever touch. AB, line AB, is parallel to line CD. They'll never touch. The lines on the ceiling in my room are parallel. Okay, the next one is perpendicular. That means they cross at a perfect 90 degrees. So AC, this one right here, is perpendicular to AB. They cross at 90 degrees. And that's the little symbol. Okay, the next one is a plane. Our floor is a plane, but theoretically it goes on forever. This whiteboard I'm holding up is a plane, but theoretically it goes on forever. Okay? And it takes 3 points to name a plane. So something like plane A, B, C. There are an infinite number of points on this plane. But if you were to draw it, or if you were to pick 3 of them, A, B, C, now we could call it plane ABC. We could also name it something like fancy letter K. It is plane K. So you can use 3 letters to name it, or 1 fancy uppercase letter. All right, why do you guys think it takes 3 points to name a plane, not just 2? If you just had 2 points, so a point and a point, okay, my plane could go through it this way, facing up, like through this way, or it could go through it flat, like this. 2 points, and it could tilt. But the minute you have 3 points, then it has to be flat in a certain position. All right, next we have a ray, and it's basically an arrow, okay? It has an end point on one side and goes on forever. Again, this is the name, and then this is actually the picture, ray AB. This one would be called DC. Notice the end point matches the end point in the name. Finally, a triangle is named by the 3 corners. You know what a triangle is. And lastly, these 3 dots mean therefore. Mathematicians are lazy. They don't want to have to write out therefore. So they'd say something like, if A is equal to B, therefore B has to be equal to A. Okay? All right. So I'm going to give you guys a minute. I want you to use that front side and see how many of these you can fill out. And I'll explain to you. It wants you to write it in symbols. Line segment AB. Okay, line segment AB. Oh, what's the symbol for congruent? Is congruent to line segment BC. See if you can use the symbols to fill this out. So, angle TRS is 30 degrees. We're talking about the measure of angle TRS, it's not an S, that is equal to 30 degrees. Whoa. Ray MN is perpendicular to line GQ. Okay, that picture would look something like this. Here's GQ, and here's MN. and they cross at 90 degrees. So that's the picture. Okay, you don't need the picture, but that's what they're saying. Now it says angle ABC is congruent to angle CDE. They are exactly the same. Line EF is parallel, and I actually always do it on a slant, is parallel to ray GH. So like here's my line EF, and then here's the ray GH, and they'll never cross. Okay, next, the midpoint of line AB is M. Basically, it has to be line segment. You can't have a midpoint of a line because a line goes on forever for both directions, so there is no middle, okay, because it keeps going. So it should have said line segment, and you would just draw the picture. Here's the segment, AB, and here's M. And then you're showing that they're congruent. This piece is congruent to this piece. There's no fancy writing for it. Ray G is an angle bisector for CDE. So in this case, you're actually drawing the picture. Here's angle CD. Notice D is in the middle. E. And G is going to bisect it. So it's going to go right in the middle, which means this piece is the same as this piece. This is ray G. Okay. On line ABCD, so A, B, C, D, it says AB is congruent to BC, and then it's saying that BC is congruent to CD. Now, I just drew you the picture here, which was kind of dumb. That's not what it's asking. It doesn't just want the picture, okay? It wants the sentence. So the sentence would be, segment AB is congruent to segment BC, and then segment BC is congruent to segment CD. So I'm going to pause and go back for a sec. This right here is the picture of this one right here, okay? If we wanted to use it for words, in order for G to be a bisector, you would say something like the measure of angle CDG is equal to the measure of angle EDG. I'm looking back at 7. 7 is this picture. It says ray is bisecting the big angle, right? So this orange thing is cutting the purple angle in half. How could you say that? You could tell the reader that however big this green piece is, the measure of angle CDG, that is the same size as this blue piece, the measure of angle EDG. Okay? And then for 8, there's my picture, and it's saying that AB is the same size as BC. Okay? And then it's saying that BC is exactly the same as CD. Okay? So it's just writing it out. Can anybody see a relationship between AB, BC, and CD. Can you see another relationship? So yes, we would notice that this one would be the same as this one. Next, the measure of angle G is equal to the measure of angle H. Measure of angle G is equal to the measure of angle H. And then this is angle G is congruent to angle H. Okay, now we're going to write these backwards. This is saying line XY is congruent to line YZ. This was just saying we have a triangle CAT with corners CAT. This one is saying segment AB. And actually, this one is wrong. They have to put the little line right here. If you don't, that's saying the measure. If you say A to B, this is the distance, and you're looking for an amount. This, with the line, is the name. So it's actually missing the lines. Put the line up there. So it's saying segment AB is parallel to segment CD, which is perpendicular to segment JK. This next one is saying angle TLC is 57 degrees. And lastly, A equals B, therefore B equals A.
We'll be using in a few minutes. These are really useful because these properties work for equal and congruent statements. Let's start with the reflexive property. The reflexive property states that a value is equal to itself. You know, like when you look into a mirror and you see your own reflection.
In geometry, we'll use the reflexive property to state that an angle or segment is congruent to itself. This may sound kind of obvious, but it'll actually come in very handy in geometry. You'll see.
We'll also be using the substitution property. Let's say we have two statements. The measure of angle 1 plus the measure of angle 3 equals 180. And the measure of angle 1 is equal to the measure of angle 2. By using the substitution property, we can switch two values that are equal, the measure of angle 1 and the measure of angle 2 in our first statement. So, the measure of angle 2 plus the measure of angle 3 equals 180. Switching the values of the measure of angle 1 and the measure of angle 2 is substitution.
Alright, now let's look at the transitive property, which says that if A equals B and B equals C, then A equals C.
Here's an example of the transitive property. Say that you get the same haircut as your friend, and your friend has the same haircut as the monkey. Then according to the transitive property, you have the same haircut as the monkey. But don't worry, it looks good on you.
Now that we've got those properties of algebra under control, we're going to get into the angle-related theorems. These are important theorems we'll be using in later proofs, so be sure to go back and review this section to make sure you get them down.
Theorem. If two angles are the complements of two congruent angles, then the two angles are congruent.
You see how that works? If angle 1 and angle 2 are the complements of angle 3 and angle 4, and angle 3 and angle 4 are both 60 degrees, then angle 1 and angle 2 must be 30 degrees.
I'm going to stop you there. You don't remember this. Complement means they add to 90. So if these two are both 30, and they're supposed to add to 90, then these two would both be 60.
So they're congruent. This works the same way with supplementary angles.
Supplementary means the two angles add to 180.
Here's that theorem. Theorem. If two angles are the supplements of two congruent angles, then the two angles are congruent. Now here's the theorem about angle bisectors.
Theorem. Every angle has exactly one bisector. Remember how we said that each segment has exactly one midpoint? Well, the same is true of angle bisectors. So as angle CUT is bisected by ray UP, we get two congruent angles, CUP and TUP.
Ow.
Wait, did you guys see what those angles said? Hold on.
What?
Oh well. The angle CUP and TUP, it's spelled cut up. When you're bisecting something, you cut it up into two pieces. Okay? So I know this video was stupid and you didn't see all of it, but the point of it is to get it stuck in your brain a little bit. So I'm going to go over these. We are stating the obvious in this unit. Okay? We're going back to stating the obvious. Heads up if your head is down. When you've done math before, if you had something like this, x minus 10 equals 40, wouldn't you solve that by adding 10 to both sides, right? And we know that it would keep it even, and so the x would equal 50. You already knew that if you added 10 to both sides, it would stay equal. Well, that is called the addition property. If you have two things that are equal and you add the same number to both sides, they're still equal, such as if you add 3 things over here, that's equal to 3 things over here. So maybe A is 3 and B is 3. Maybe C is 1. If you add 1 on this side and 1 on this side, they're still equal. Okay, so it's stating the obvious. Same thing works with subtraction, multiplication, and division. If two things are equal, then A divided by C is the same as B divided by C, except for C can't be 0 because you can't divide by 0. Okay, we also have the distributive property. You guys know that we can distribute like this and it stays equal. Okay, we have the reflexive property. Something is equal to itself. It was like that dude looking in the mirror. Okay, when you look in the mirror, your reflection is the same as yourself. Or for example, if you have two triangles, the blue triangle and the green triangle, this segment BD is the same length for the blue triangle as it is for the green triangle. It's the same as itself. Okay, symmetric means that they can switch, right? 2 equals to 3, just like 3 is the same as 2. Transitive, this is the monkey property. Okay, this is what was on the video. You have the same haircut as your friend. The friend has the same haircut as a monkey. Therefore, you have the same haircut as a monkey, right? It's the same thing we did with these earlier. If red is the same as green, and green is the same as blue, then obviously the red would be the same as the blue. You transfer the properties. And lastly, substitution. If two things are equal, you can replace it. So if you had the equation y equals 3x minus 12, but you happen to know x is the same as 2, you could substitute in a 2. Okay? When I'm absent, they replace me with a substitute. Okay? And that becomes the teacher for today. All right. So I'm going to have you work on these with your group, but I want you to see if you can identify the property that's being used. For example, if 1.7g squared equals 22, then 22 equals 1.7g squared. Look, they switched. If you go back here, which one of these allows you to switch? oh, the symmetric property allows them to switch places, so this must be B. See if you can do 1 through 6, and when your group has it, stand up. All right, Lisbeth, what did you guys get for 2? Talk to your group. Connor, help your group. Lisbeth. Hey guys, quiet. Lisbeth, what'd you guys get? E. So it looks like it's E. It's actually, oh, not even on there. It should be. What are they doing to both sides? How did they solve this? They subtracted 5 from both sides, so it should be the subtraction property. I don't know why it's not on there, not my notes. Okay, it is close to the addition property, so I see why you put that. No wonder she was silent. All right, next, 3. Rachel, what'd you guys get? Yep. A, it is the reflexive property, okay? It's equal to itself. They rewrite them, but it still means it's the same thing. Okay? 4, I don't know. Chase, what'd your group get? See, it is the transitive property. You have the same haircut as your friend has the same haircut as a monkey, therefore you have the same haircut as a monkey. All right, 5. The group in the back, what'd you guys get? Kevin's group, what'd you guys get? What'd you get? D. It is actually, it could be F, or you could call it, it is F. You could also call it division property. And here's why. How do you get rid of 1/2? You can multiply both sides by 2, and you would get your answer. That's not how I solve, though. I divide by 1/2, and you'd still get your answer. So you could have said multiplication or division. And then lastly, what did they do? They said x plus y equals 15, but oh look, x is -7, so they replaced -7 for x. That is the substitution property. All right, let's do these last couple. If AB plus BL equals 19 and BL equals LE, what can you conclude? Okay, well, substitution. If we know that BL is equal to LE, we could rewrite it and say AB plus LE is 19. We just replaced them with each other. Okay? If AB is equal to BL and LE is equal to AB, what can you conclude about the transitive? Well, this one, yellow is equal to green, and yellow is equal to blue. Therefore, these two have to be equal. BL is equal to LE. If B is the midpoint of AL, what can you conclude about the definition of midpoint? Saying this is the midpoint. That means it's in the middle. That means that AB is equal to BL. They're the same length. Or you could say segment AB is congruent to segment BL. This first one is talking about that their lengths are the same. So maybe they're both 5. And the next one isn't talking about the lengths. It's saying since their lengths are the same, and the only thing they have is length, they must be 100% the same. All right, any questions on that? Okay, it says, we're going to look at this picture. It says, if the measure of FEG, so FEG plus GED, this much plus this much, the whole thing is 87. Okay, and then it says GED, it says this piece no, this is a typo. Awesome. This should say that GEF right here. Okay, change that. Sorry, it's what happens when I don't use my own notes. GEF, and I literally put my finger on it to figure out which one it is. GEF is the same size as DEH. Well, what can we conclude? If blue plus green is 87, and we just said that this is the blue amount, well, this is the blue amount as well, then these two must also equal 87. So we could conclude that the measure of angle DEH plus the measure of angle GED also equal 87. All I did was replace this blue one with this one. I substituted. Okay, I'm going to skip this one because we don't need it for time. Let's look at the last one. Okay. It says the measure of angle T equals 90 minus x. Find the measure of angle T if x is 49. So I'm going to say, okay, the measure of angle T equals 90 minus x. But oh look, x is 49. 90 minus 49 is 51. Okay? Well, then the measure of angle T is 51, and we used it by the substitution property. I don't love this, so I'm just kind of going over it. All I'm trying to say here is, look, we could plug in for x 49 and get our answer. And how come we could do that? Because of substitution. All right, flip to your white page. It says find the indicated length. So I didn't actually, for some reason, oh, sorry, right here we go. State the properties that justify each conclusion. It's the same thing we just did. Look, given DE, we can conclude that DE is the same as itself. Which one of our properties from last time said something is the same? You look back at your notes and you would see that it is reflexive. So that is the reflexive property. Okay, you're going to fill out the properties here. And then the two properties that are on the notes are that if you add two pieces together, you make a whole. So let me show you this. It says, find the measure of angle MBC. Or sorry, the measure of angle MBC is 26. On all of these, you want to fill in the picture. The measure of angle ABC, this much, is 64. And it wants you to find this piece. How could we do that? Okay, we could subtract. You could say, look, the whole thing is 64 minus the red part and I'll get the orange part. So the measure of angle ABM is 38 degrees. Could you have written that as an equation? Yes. You could have said, look, 26 plus x, this is the x, the thing we don't know, equals 64, and then minus 26 from both sides to solve. But when they're really simple, you don't need to write an equation. Okay? I'm going to set you up for 3, and then I'm going to do one on the back for you and then let you work with your group. Let's look at 3. Always fill them in. The measure of IHG, this much, IHG, is 34x. The measure of IHC, this much, is 5x plus 5. 5 times some mystery number plus 5. And CHG is 140. Here's the thing that you need to use, and I don't know why it wasn't on the notes. Another teacher took it off. Would you agree that the orange angle plus the green angle equals the red, the whole thing, right? Part plus part equals whole. So we would say 5x plus 5 plus 140 equals 34x. And then you would solve. In order to solve this, you need to get all the x's on the same side. So I'm going to write a line through the equals, minus 5x from both sides, and combine these two. So we get 5 plus 140 is 145. 34x minus 5x, 29x. I'm going to pause right there just because I don't know where you guys are at. How many of you are comfortable with this type of solving? Okay, we'll have to do some practice. Uh-oh, I hope I just hit pause, but I didn't actually hit pause. Now we want to divide both sides by 29 using the division property. 145 divided by 29 is 5. So we know x is 5. Did I actually answer the question? No. I want to know how big the angle is. I want to know how big IHG is. Oops. IHG is the red one. IHG. Well, it is 34 times x. 34 times 5 is 170. Okay. All right, I'm going to do one on this other page. Same thing, but with angles. Let's look at 7. Wouldn't you say that this much x plus 5 equals 2x minus 7? Wouldn't you guys agree that's what the picture says? Now solve. Step 1, draw a line through the middle. Now get all the x's on the same side. So I'm going to minus this x to the other side. Doesn't matter which side you go to, but I don't like negatives. So I have 5 equals 2 take away 1 is x minus 7. Now I'm going to add 7 to both sides. And I have x equals 12. And it said to solve for x, so I don't have to do anything else. Okay, work on your groups until I tell you to clean up. You have almost 15 minutes. See how far you can get on this worksheet. The rest you have to finish as homework. You also have 4.1. Go.